Hi, my name is Mark Parrish. I represent Turpin Sales and Marketing. This is the fourth section in our machining basics training, and we're going to concentrate today on insert identification. So why are Turpin Sales and Marketing putting these presentations together? Well, the machining industry is facing a massive problem right now in lots of ways, but specifically in the shortage of skilled machinists. So we put together a series of presentations which are very basic, and they were developed with the intent to stimulate some interest from people who may want to come into this industry who've never considered it before. So, who are Turpin Sales and Marketing? We're the leading manufacturer sales representative team in the metalworking industry in the Northeast. We represent superior products and have extensive knowledge in the metalworking industry that our customers have relied on for over 30 years. We have focused on cutting tools, work holding, tool holding, fluids for many industries, aerospace, firearms, medical and automotive. Through our technical expertise and selling skills, we provide the end user and distributor with increased productivity and profitability. This is achieved by assisting our distributors, end users, in presenting and implementing the quality products that we represent to the end user in a knowledgeable and professional manner. The metalworking industry is facing many challenges right now. Supply chain, material availability, but I believe the biggest one we're facing is the skills gap. So what is the skills gap and what can we do about it? The skills gap is basically a shortage of skilled labor in the manufacturing and machining industry. No one's going to trade school. No one's doing apprenticeships. Skilled labor is very difficult to find. It's predicted that 3.5 million manufacturing jobs will be unfulfilled in the next decade, which will be devastating for this industry. So what can we all do to improve this situation? Do you have existing employees that have an interest in manufacturing? Maybe you hire a person with mechanical aptitude, good work ethic, but no manufacturing skills. So what's the solution? Train your own. So Turpin Sales and Marketing have put together a very basic series of training presentations to help to inspire people who may want to know more about this industry and help to bridge the skills gap. As you can see from this slide, inserts come in many shapes and sizes, but the majority of the turning inserts and boring inserts available in the US conform to either an ISO or an ANSI standard. There are some exceptions to that, but the majority of them will comply to the ANSI and ISO standard. So the next slides will guide you through how to identify the inserts from the nomenclature. This slide shows you the difference between the ANSI, American National Standards Institute, or the ISO, the International Organization for Standards. Basically, the ANSI is based on inch and the ISO is based on metric, but they are interchangeable regardless of the manufacturer. So you could have a Sandvik turning tool holder and a Kennametal insert would fit into that. So in turning and boring, everything is mix and match as long as it conforms to the ANSI or the ISO standard. So what is an insert? An insert is, as you can see on the slide, a piece of cemented carbide, ceramic, cermet, diamond, polycrystal diamond, and these are all manufactured to a specific shape and dimension according to the ANSI and ISO standards. These inserts fit into a milling cutter, a boring bar, a drill, a turning holder, and they're used to cut material. The insert may have grooves and bumps. We like to refer to these as chip breakers or chip formers. These help to break the material, and so instead of forming a long stringy chip, they form a small chip that is much more manageable. We'll use this format on most of the slides, so I'll show the ANSI on the top and the ISO on the bottom. Again, ANSI is inch and ISO is metric based or millimeter based. So the first letter you can see in this case is T. If you look down the chart, the T stands for a triangle. So that first letter really shows you the shape of the insert. I'm not going to read down them, but you can see C is a diamond, 80 degree, D is a 55 degree diamond, S is a square, etc., etc. So in all cases, that first letter in the nomenclature describes the shape of the insert. The second angle, in this case an N, describes the relief angle, which is the angle under the insert. You can see the N there is 0 degrees. Some people say 90 degrees, but you can see it's a 0 degree corner. The angle increases as we get to the E, which is 20 degrees. You can see that the 0 degrees, or the N, is much stronger than the E, 20 degrees. I like to use the analogy of, would you try and spread butter with a knife that's 0 degrees, or would you spread butter with E, 20 degrees, the sharper? And that's the case. The 0 degrees is a stronger edge, so would generally cut harder materials. The E is a weaker edge, but would generally cut softer materials. The next letter in the nomenclature, in this case an M, tells us the tolerance of the insert. It tells us 3 dimensions: the IC, inscribed circle, the thickness, and the nose position. So you can see the M in the chart represents plus or minus 2 to 5 thou on the IC. It represents plus or minus 5 thou on the thickness, and represents plus or minus 3 to 7 thou on the nose position. You can see that a G is a very tight tolerance. That's 001, or plus or minus 1 thou. And that normally is a ground insert, where the M is normally a molded insert. But if you look at that third letter, it will tell you the tolerance for those 3 dimensions. The fourth of the letters, in this case G, tells us if it has a hole and if it has a chip breaker. So we'll use the G, and does it have a hole? Yes, hole referring to in the middle of the insert. Does it have chip breakers? Yes, it has a double chip breaker. And what type of hole is it? It's a straight through hole. Just looking at another one, if we look at D, for instance, that also has a hole but no chip breakers, so it is a very plain top on the insert. And the hole has a countersunk in it. So looking at that fourth letter and referring to the chart, we can now identify what the chip breaker is and what the hole type is. We now move to the first number in the nomenclature. In the example shown here, we have ANSI with the number 4 and ISO with the number 22. This is where the two systems differ a little, as the 4 represents the size of the inscribed circle, and the 4 represents the number of eighths. So if we look at 4 eighths, that would be half an inch. So if we look down the chart on the right under IC size ANSI, you will see the 4, which is the number, and then the size of the inscribed circle, which is half an inch, or 4 eighths. If we look further down, you'll see the symbol is an 8, which is 8 eighths, or 1 inch. So the dimensions shown there are represented in eighths of an inch increments. The ANSI is a millimeter, so 22 refers to 22 millimeters. It also refers to the edge length, not the inscribed circle, as with ANSI. You can see in the chart below, under each shape, the different edge lengths that are available. So that number, if we take a round insert, we take a 10, that number would be number 10. So that would be 10 millimeters edge length. The next number in the chart, the example shown here shows ANSI as 3 and ISO as 4, represents the thickness of the insert. The 3 represents 3/16. So if you look down, you'll see the number 3, and that will be 0.1875, or 3/16. If you look at the number 4, that would be 1/4 of an inch, or 4/16. The metric is very simple. It is in millimeters. So an 01 is 1 millimeter thick. The example we have here is 04, which is 4 millimeters thick. Very simple. The metric very simple. The ANSI is in 16th increments. The next letter in the example here for the ANSI 2 and for the ISO 08 refers to the nose radius of the insert. On the ANSI, it is in 1/64th increments. So if I look at a number 2, as shown on the chart, that would be 1/32nd, or 2/64ths. The metric again is simple. It is a millimeter value. So you can see in the example here, 08 is 0.8 millimeters. A 16 is 1.6 millimeters. The next letter in the nomenclature for ISO and ANSI describes the chip breaker or chip former. I have to say here that a lot of manufacturers shy away from ANSI and ISO. They use their own nomenclature. So if you're using a Kennametal, I would suggest you go to the Kennametal website or catalog and start looking through the chip breakers. The chip breaker really controls the depth of cut, feed rate, or is dependent upon the depth of cut and feed rate. If you're roughing, finishing, general, it would require a different chip breaker, as it would for different materials. After saying that, there is an ISO and ANSI designation for this letter, even though a lot of manufacturers do not use it. You can see the EFST, and really take a look at the diagram on the right. So an E would be an edged hone. So you can see that the hone on the corner, the F would be a sharp corner, the S would be a chamfer and a land, and the T would be a T-land. But not manufacturers use these designations. The next letter, which is R, L, or N, refers to the direction, right hand, left hand, neutral. Really simple. The final letter in this chart actually refers to the application. F is for finishing, S is for light cuts, U general purpose, M roughing, H heavy cuts, etc. So that is determined by the application that you're using. Most insert manufacturers have their own grade designation, but there is still an ANSI and ISO structure for this. So if you look down the left-hand side, you would select which type of material you would want to cut. So if you wanted stainless steel, you would look for an M. If you wanted cast iron, you'd look for a K. If you wanted hardened steel, you would look for a H in that position in the nomenclature. You also see that they're color-coded. This color coding is common throughout the industry and can be found in most manufacturers' catalogs. You'll see on the right-hand side, it has a P designation for steel, but it also has 05 to 40. So we can look at this two ways. If you wanted to cut a really nasty material, you would use a P40. If you wanted to cut a very stable material, you would use a P05. The insert itself, the carbide, P05 is much harder carbide than a P40. So obviously if you use a P05 it could chip, where you may need a P40 to be more durable. As I said earlier, most of the major manufacturers use their own grade prefix. This chart may help you identify whose grade is who. So Sandvik used the first two letters of their grade, two letters of their grade as GC. Kennametal used KC. Walter used WA, etc., etc. So if you look for the first two letters within the grade of the insert, you may be able to identify who the manufacturer is. A great place to look is on the box. A lot of manufacturers will put the ANSI and ISO color coding and letter coding on there, as you can see on the Sandvik box. That will help us determine which grade would be best suited for the application that we're trying to achieve. Just a little slide that shows the strongest edge to the weakest edge, and that goes from left to right. So you can see that the round insert is the strongest insert and the diamond insert is the weakest insert, and so on. That concludes this portion of the training on insert nomenclature identification. Hope you found it interesting. We'll have more coming out soon, so please visit us at www.turpinsales.com or our YouTube channel, Turpin Sales. Thank you for listening.